Now that you have been introduced into how to find the square roots of negative numbers and how to write complex numbers with the real component, let's look at some operations on complex numbers. The first is going to be adding and subtracting. If you need to add two complex numbers, then you just add their real components and add their imaginary components. With subtraction, same operations there. So essentially we're going to group the real components and the imaginary components together and add as normal. In example 1, if I needed to add these two complex numbers, then my real component would be 3 plus 2. And then I would add to that the imaginary components with I. That gives me then 5 plus 1i. Most of the time we don't write the 1 just like we wouldn't with variables, so you could write this as 5 plus I. On B, just like we would do with distribution in algebra, we want to make sure that I subtract both of those terms, meaning the real component is negative 5 minus negative 11 plus 7 minus 2 with my I. When I subtract negative numbers, that is the same operation as adding. And so I would then combine my real components and combine my imaginary component to get my final answer. Let's also talk about multiplying complex numbers. If you need to multiply a complex number by a real number, then you just distribute that inside like we do in algebraic expressions. So I have 4 times 2 plus 4 times 5 with my I, and that would be 4 times the complex number 2 plus 5i. If you need to multiply two complex numbers together in which you have imaginary components with each one, you can use FOIL just like you did in algebra or pre-algebra. However, I personally like to use a Punnett square. When I organize my Punnett square, I put my first term here on the vertical piece, and then my second term on the horizontal piece. It is just a fancy organizational tool for FOIL. You multiply to find the inside pieces. So 4 times 2 minus 4 times 5i, 2 times 3i minus negative 15. I times I gives me I squared. I'm then able to see like terms really easily, and it allows, I think, for me to have less mistakes. Again, if you would like to use double distribution or FOIL, you end up getting the exact same thing as this organizational tool, Punnett square. However, we are not done. You need to substitute back in that I squared is negative 1. Therefore, I get 8 minus 14i times negative 15 times negative 1. This gives me a positive 15. So I would have 23 minus 14i as my final answer. The last piece of these complex number operations is realizing that every single complex number has a conjugate. It is found by just changing the sign of the imaginary part. Let's just find the complex conjugate of both of these numbers given here. The only thing I do to find the complex conjugate is change the sign of the imaginary part. In B, I might want to rewrite with the 0 in place of my real component so that I can then say my complex conjugate is just changing the sign of the imaginary part, or just 1/2 I. Let's then add the two numbers together and see what happens. So if I have 2 plus I root 5, and I add to that 2 minus I root 5, I would get 4. And then notice I have the exact same number with a positive and a negative, so I would have plus 0i, or my result is 2 plus 2, which is 4, or just adding the real component, because when you have plus or minus the same imaginary component and you add them, they would cancel out. Similarly here, if I wanted to write this with the 0, just to make sure I understand the full placeholder here, well, I'm going to end up getting 0 plus 0, which is 0, or the addition of just the real component pieces. Let's look at what happens when I multiply an imaginary number by its complex conjugate. I would get 4 minus 2i root 5 plus 2i root 5. And then when I multiply here, I would get negative I times I, so I squared, root 5 times root 5, so root 5 squared. Look at my diagonal. I get the same term when I do my outside times inside piece, so it goes away. So I would have 4 minus, remember I squared is negative 1, square root of 5 squared, those cancel, and I get 5. So I get 4 plus 5, which is 9. Again, when I multiply two complex numbers, I end up getting a real number. All right, let's look here. If I have negative 1/2 I, and I multiply that by its complex conjugate, I would get negative 1/4 I squared, negative 1/4 times negative 1, when I do the substitution here, gives me 1/4. A positive complex number. Now be careful. I believe it's always, yes, it should always be, because even if these are negative, when you multiply, you get positive. Yes, you should always get a positive real number when you multiply two complex numbers. Maybe verify that for yourself, but I'm pretty sure that that's always going to be the case.